Today we're in the textbook on pages 376 and 377. It'd be helpful if you had two colored pencils, blue and red. Your homework's going to be page 378 and 379. Before we start lesson 8, what we've been working with thus far have been sine and cosine equations like y equals a sine x plus c and y equals a cosine x plus c. And c we know as the midline, and we have a formula for that. But if we're thinking of it as a whole in the form of a transformation, the plus c outside the function, remember, is a vertical shift. And the a was a dilation of a to the y value. This is a vertical stretch. Now today we're going to look at a final transformation. So a final transformation will horizontally stretch or compress our sinusoidal graphs. It's important to be able to do this, especially when modeling real-world phenomena, because most periodic functions and sine and cosine functions are considered periodic functions, do not have a period of 2 pi. Well, what is period again? Period is the length of one complete cycle. Period is the length of one complete cycle. And all the graphs we've worked with so far, the length of one complete cycle was from 0 to 2 pi, like this cosine curve here. The length of one from max to min, back up to max, is a length of 2 pi. On the grid below is a graph of the function y equals 3 cosine x. We are not using our calculator. So without a calculator, sketch y equals 3 cosine 2x on the same axes. Right, so I'm going to switch to blue pencil for this. Well, first off, let's look at y equals 3 cosine x. Right? The a value is 3. The c value is 0. This is back to my regular writing utensil, sorry. So our midline is the x-axis because that's y equals 0. And cosine starts off the midline. So it starts 3 above. Here's our max. Comes down to our min, back up to our max. This is one complete cycle of our cosine. Now switching to blue. Sketch y equals 3 cosine 2x. Well, this 2 right in front of the x value. Remember when we were working with transformations back in Unit 7? When we're inside the parentheses, we kind of want to think of the opposite. So instead of a dilation of 2 to the x, it's a dilation of a half to x. So let's take our maximum, our starting point here. What's the x value? It's 0. So a half times 0 is 0. Go to this point here on our midline. Our x value is pi over 2. 1/2 of pi over 2 is the same as 1/2 times pi over 2, which would be pi over 4. Or just take this distance, split it in half. Our minimum point, the x value is pi. 1/2 times pi is a half pi, or pi over 2. This point here, sorry, I'm just noticing again, this is where this is wrong. This is 3 pi over 2. A half of 3 pi over 2 is 3 pi over 4. So that's 3/4 of pi. Where if I think of from here to here, I'm going to get halfway. So 3/4 pi would be there. And now our max, back up to our max. X coordinates 2 pi. Half of 2 pi is simply pi. Or if I'm going from here to here, go half the distance now. So what's happened here, if we connect these 5 points, this has been a horizontal compression, right? We went from this wider wave to a much narrower, more compressed wave. So the length of this one complete wave is now a distance of pi. So from 0 to pi, we have this one complete cycle. And then from pi to 2 pi, we'll have another complete cycle. So meaning max, midline, minimum, midline, max. And cosine is symmetric with the y-axis, so we can reflect each of these points over the y-axis. B, how many full cycles or periods of this function fit within 2 pi radians? So from 0 to 2 pi, there are 1, 2 full cycles. The period is the length of one cycle. So the length of one cycle is pi radians. So we say our period is pi. Switching to red, not using our calculator. Without a calculator, sketch the graph of y equals 3 cosine a half x on the same axes. Okay, so I'm going back to our original 3 cosine x. And now this is going to be a dilation of 2 to x. So if I take this point here, starting at our max, 0, 3, take the x-coordinate 0, times it by 2, it stays there, it's still 0. If I take this point here, pi over 2, 0, pi over 2 times 2, pi over 2 times 2, the 2's divide out, or you're going to get 2 pi over 2, which is same as pi. So that's going to move to pi 0. And the minimum here, x value is pi, times it by 2, 2 pi. And that's all we can go there. So if we connect these, try to make this a curve, not a straight line. down. There's a curve to that. And now reflect over the y-axis. And again, I'm going to go back. I apologize with the labeling here. This is our negative pi over 2. This is our negative pi. Negative 3 pi over 2 is correct. It's negative 2 pi. So here from 0 to 2 pi, this is only half a piece of a cosine cycle. So how many full cycles or periods of this function fit within 2 pi radians? Only 1/2. Only half. Well, what is the period, right? What is the period? We have this formula here. The period is equal to 2 pi over b. And in this case, a is 3. What's in front of x is b. So substituting 1/2 in for b into our formula, 2 pi divided by 1/2, dividing by 1/2 is the same as multiplying by its reciprocal. So that's 2 pi times 2, which is 4 pi. Meaning it would take a distance of 4 pi to get one complete cosine curve. And that's actually what we have here. We have one complete, what we call inverted cosine curve. Right? Cosine, if this is our midline, the x-axis is our midline. This one's starting here, down here, starting at its min, comes up to its max, back down to its min, back to the height it started at. This is one complete cosine curve. It's just upside down. And what is the length? Well, from negative 2 pi to 0 is 2 pi radians, plus 0 to 2 pi is 4 pi. So the period, capital P, of a sinusoidal function is an extremely important concept. It is defined as the horizontal length needed, so it's the length for one complete cycle. The period depends on the b value. In the general equations, y equals a sine bx and y equals a cosine bx. So here's our formula. So another formula you need to memorize. Period capital P equals 2 pi divided by b. And frequency is b over 2 pi. I like to use the words frequency and period are reciprocals. So whenever I'm asked for the frequency, it's simply the reciprocal of the period. Frequency is reciprocal of period. In exercise number 2, we want to consider the graphs from exercise number 1. For each below, state the frequency and the period. Okay, so we're first going to state the period. So period is equal to 2 pi over b. Our b value here is 1. So 2 pi over 1 is 2 pi. And if we look at the graph of y equals 3 cosine x, one complete cosine curve took up a length of 2 pi. The frequency is the reciprocal. So I'm just going, it's the recip of 2 pi, which is 1 over 2 pi. So always going to do the period first and then the frequency second. Y equals 3 cosine 2x. The period equals 2 pi over b. B is 2. 2 pi divided by 2 is pi. And we saw that. This was the graph of y equals 3 cosine 2x is in blue. Here's one complete cycle. The period, the length of that cycle, that one cycle is pi. And C, y equals 3 cosine half x. Oh, apologize, let me go back. This frequency is the reciprocal of pi, which is 1 over pi. The period, 2 pi over b. Keep writing the formula because you have to memorize it. B value is a half. 2 pi divided by a half. Dividing by a half is the same as multiplying by the reciprocal. It's the same as 2 pi times the reciprocal of half is 2, which is 4 pi. And the frequency is 1 over 4 pi. Number 3, determine the period of each of the following sinusoidal functions. So if we want period equals 2 pi divided by b. And b is what is in front of x. So this is a, this is b. So the period is 2 pi over 4, which reduces to pi over 2. Y equals 8 cosine pi over 3x. This is A, this is B. Period is 2 pi divided by pi over 3. Dividing by the fraction, pi over 3 is the same as multiplying by the reciprocal. 2 pi times 3 over pi. Pi's divide out. The period is 6. And C, y equals negative 12 sine 2/3 x. A is negative 12, B is 2/3. Period is 2 pi over b. So 2 pi divided by 2/3. Dividing by the fraction 2/3 is the same as multiplying by the reciprocal 3/2. That's 6 pi over 2, which reduces to 3 pi. Number 4, sketch y equals 2 sine 4x on the grid below for one full period. To the left and to the right of the y-axis. Okay, so we want one full period to the left. And then one full to the right. Well, of course, I'm going to go to the right of the y-axis first. One full cycle. Well, so we need to figure out what that is, right? The period's 2 pi over b. B is 4. So that reduces to pi over 2. So I go to the end here on my left-hand side. This is pi over 2. From here to here is a length of pi over 2. Halfway, what is half of pi over 2? It's pi over 4. What's half of pi over 4? It's pi over 8. What's midway between pi over 4 and pi over 2. Okay, well, let's go this way. This is 1 pi over 8. This would be 2 pi over 8, right? 2/8 is equivalent to 1/4. So this would have to be 3 pi over 8. And then 4 pi over 8 is equivalent to 1/2. There's no C value, right? This would be a plus 0. So our midline is the x-axis. We have to fit in one complete sine cycle from 0 to pi over 2. Where does sine start? It starts on the midline. So it starts here. It's going to go up to its max. Well, I always like to do start end. So start on midline, end on midline, midway between on midline. If the A value is 2, that means between 0 and pi over 4, midway between, it's going to go to a height of 2. It's going to be 2 units above the midline. And between pi over 4 and pi over 2, it will be 2 units below the midline. It's symmetric with the origin. So between here and here, it'll go down to its minimum. And between negative pi over 2 and negative pi over 4, up to its max. Exercise number 5. The heights of the tides can be described using a sinusoidal model of the form y equals a cosine bx plus c. If high tides are separated by 24 hours, which of the following gives the b value of the curve? Okay, so 24 hours, that's the length of one complete tide, right? It's like starting at high tide, going down to low tide, back up to high tide. And it's telling us that that length is 24 hours. So that is the period. And we know that period equals 2 pi over b. You have to memorize that. If I think of this as a proportion, sorry about that. If I think of that as a proportion, p over 1 equals 2 pi over b. And if I were to cross multiply, I get pb, not peanut butter, equals 2 pi. Solve that for b. We've got p times b, so divide. b equals 2 pi over p. It's the same as you can simply switch those. Because if these were switched, you're still multiplying. When you would cross multiply, you still end up with pb equals 2 pi. So you also want to know that b is equal to 2 pi over p. Which of the following gives the value, the b value of the curve? Okay, so if I'm using this, b equals 2 pi over p, and our period is 24, 2 pi over 24 equals pi over 12. Option 3. Just looking at the homework, you want to determine the period. So write down that the period equals 2 pi over b. You only need to pull out B here. I'm actually going to do D for you. So period equals 2 pi divided by 4/3. Dividing by 4/3 is the same as multiplying by the reciprocal. The 2 and the 4 are reduced, so in reduced form, 3 pi over 2. Same thing here, you're determining the period, which only involves the B value, has nothing to do with the A or the C. Number 6, consider the curve whose equation is y equals -2 cosine pi over 8x plus 3. Determine the period of this. What is its amplitude? That's the absolute value of A. What is the midline? Then sketch the function for one full period on both sides. All right, so I mean, definitely stop the video when you're going to attempt your homework, okay? And after you have attempted this, then go back and check, all right? So you're stopping the video, going on to your homework. Two pi divided by pi over 8. Dividing by pi over 8 is the same as multiplying by the reciprocal. So 16. We want full period on both sides of the y-axis. So that means since the period's 16, it's going to need a length of 16 to get one cosine, one complete cosine cycle. Half of 16 is 8, half of 8 is 4, between 8 and 16 is 12. The amplitude is 2. The midline value is 3. Okay, so we start with the midline, right? We already have our scale. All right, we did that already. Draw the midline. Cosine starts off the midline. The A value is -2, right? So you want to start 2 units below the midline. One complete cycle is going to end at that height. Midway between, it's going to be 2 units above. So it starts at its min. After 16 units, it's back at its min. Midway between, it reaches its max. And reflect over the y-axis. Remember, cosine is always going to start off the midline. If this was a +2, then it would have started at 2 units above the midline. But since this is -2, it starts 2 units below the midline. Okay, thank you for your attention and have a wonderful day.